The question is saying that figure 8.5 shows a capacitor made of two circular plates, each of radius 12 cm and separated by 5 cm distance. The capacitor is being charged by an external source not shown in the figure. The charging current is constant and is equal to 0.15 ampere. Now we have to calculate the capacitance and the rate of change of potential difference between the plates, and we also need to obtain the displacement current across the plates. And the third, we have to tell whether Kirchhoff's first rule or the junction rule is valid at each plate of the capacitor. Now we know that capacitance is defined as C equals to epsilon naught A by D, which depends upon the geometry of the plate. Here we have been given that the radius of each plate is 12 cm and they are separated by 5 cm distance. That is, the radius of this plate is 12 cm and they are separated by 5 cm. We also know that rate of change of potential difference is dV by dt. Now V in terms of the capacitance is defined as Q by C, where Q is the quantity of charge. Now if we differentiate V with respect to T, then we will come to the expression of 1 by C dQ by dt, and we can write dQ by dt as I, that is current. So rate of change of potential difference would be equal to I by C. Now let's find out the expression for displacement current. Now we know that displacement current is defined as epsilon naught d phi E by dt, or the rate of change of flux, and flux is defined as E dot A, the dot product of electric field and the area vector. Now E is defined as sigma by epsilon naught, where sigma is the charge density of the plate, so we can write it as Q by A. Now if we find out flux, then A will get cancelled out. Now flux would be Q by epsilon naught. Now displacement current is defined by epsilon naught d phi by dt. After substituting this flux in this expression, we will get epsilon naught multiplied by dq by epsilon naught. So it would be cancelling the epsilon naught and we will get the value of displacement current equals to I. So the displacement current would be equal to conduction current. Now let's compute capacitance. Capacitance was epsilon naught A by D. After substituting the area and the displacement and the distance between them, we will come to the conclusion that the capacitance is equals to 8 picofarad. Now computing the rate of change of potential difference dV by dt, we already know from here we have calculated that dV by dt would be equal to current by capacitance. Now substituting that in this expression, we will get a value of 1.87 into 10 to the power 10 volt per second. Now computing displacement current, we already saw from this derivation over here that displacement current would be equal to conduction current. So displacement current would be equal to 0.15 ampere. Now it follows the Kirchhoff's junction rule, as at each plate the conduction current flows into the one side while the displacement current flows out of the other side.